Hello, everyone. This is Fantastic Facade with Now That's Debatable. We are live. Apologies for being a few minutes late. We were polishing up our sound issues that we had last week. We did not want to repeat. Uh, with that in mind, we are live and on the air, and we highly welcome you to call in if you have a opinion or questions about the James Webb Space Telescope, because that's going to be our topic this week, as indicated by our title. I have my faithful co-host with me, Geocentric Skeptic. Are you with me, Geo?
I am.
Perfect. Welcome. Hope you're doing
Going on,
well.
bro?
Oh, living life. Just running a few minutes behind as always.
Oh, good. Better late than never.
Better late than never, indeed. Much like the James Webb Space Telescope.
So true.
It's been in
So
the
true.
works since before we were born, so
Yep.
let's change the
30
screen
years in the
over.
making.
30 years in the making. 30 years
Uh,
plus in the making.
yeah.
I should have everything up on the screen now. I'm gonna change the background image. I had it more set earlier. Let me change that. Um, but yeah, 30 years in the making for the James Webb Space Telescope, and if you've been living under a rock, um, you guys missed it. It was Christmas Day of just last year, so about 2 months ago, the James Webb Space Telescope launched. And whether you celebrate Christmas or some other holiday, the world should consider it a gift. I,
Definitely.
I think it's the best gift that the government may potentially have given to us by draining our tax
I
dollars.
agree. Yeah.
so,
Out of all the
I'm
things the government has given, yes, this is
yeah,
by far the best
it's
gift.
yeah. So far, has the potential to be the best gift the government will ever give to us. This photo is provided courtesy of NASA. NASA allows you to use photography from their website because they are government owned. I will attribute the link to this particular photo in the comments and or when I upload the videos. That way there's no issue anywhere. But with that in mind, uh, the photo in the background, which is a little hard to see, but because it's massive and I didn't get to choose it until last second, but it is a picture of the center of the James Webb Space Telescope, which is just this really, really massive infrared camera, which is pretty cool. Uh, Geo, you recommended the topic. Do you want to start us off or take us on the journey or give us a mild introduction other than what I've said so far?
Sure. So, you made a joke right at the beginning about like better late than never, and yeah, it this was the James Webb Telescope. It was originally supposed to launch back in 2007. So, this is when you and I were sophomores in high school.
Yep.
So now we're in our 30s,
Yeah,
and
we're
it just
revealing our
launched.
revealing our ages to everyone here, but yeah, this has been a long time coming. Um,
Yes.
it's been in production and the engineering and design stage has existed even before then since the late 80s.
Yeah.
So
And
here we are in 2022. It launched officially in December 2021, but
yep, launched on Christmas Day.
yeah,
So about 6 days prior, just a week prior to 2022,
yeah,
launched.
and it had been like in the physical process of being made since the early 90s, if I'm not mistaken, and design concept and all this other stuff had been in the works since at least 5 years before that.
Yeah.
So
And yeah, it took a long time, but this is definitely worth it for what they wanted to put into it. Because one thing, by waiting this long, we've had all this time to put the most advanced technology we could into it. So if it had launched in 2007, it would have had at best 2007 technology. So now is that would have been cutting edge back then, but not necessarily right now. So by the way, we definitely have a better telescope, and because of its orbital path, that's the main reason that it was delayed so much. They were doing diagnostic after diagnostic, doing every sort of test because everything had to be perfect. You don't remember because you were like probably one or not even born, as was I. But when Hubble first launched, it had a bunch of problems, right? Like I think a lens cracked. Then
Yeah, yeah.
another
So
time,
I can tell you what it was, because I've done. Space is one of my favorite hobbies. Although I'm no physicist and I can't get you much beyond a basic level of understanding, I know exactly what happened with Hubble because I have done a lot of research into it.
was it?
Essentially, the grind of the glass for the lens for Hubble was at an incorrect angle. And what that meant is what we thought it should be versus how it actually settled once in orbit was different. So we had this calculation and it was wrong. That's plain and simple. We got the math
So
wrong. And
basically, and it was essentially blind.
well, it wasn't blind. It was just imagine being punched in the face. It was kind of like
Trying to
that.
see.
Like you can still
I
see, but
look
you're
through a
looking through a
straw.
black eye.
Yeah.
Yeah.
So I
So
mean that that
that's kind
kind
of what was
of that
happening.
kind of
And we sent
if you can't
like a technician, several technicians via astronaut to actually put essentially a contact lens on Hubble. So what we did
yeah.
was instead we couldn't replace the lens that was there. It would have taken way too much work. What we did was
So
we made a contact lens essentially to fit over the current lens camera of Hubble, which made
yeah.
it
So
appropriate.
the main thing is this this post launch maintenance is not an option with the James Webb. It is orbiting a million miles away from Earth.
Yeah, so I
So
mean, to put things in perspective, like we did spacewalks to do maintenance on Hubble, and it takes a fraction of the time to get there than it would to get to where James Webb is going to eventually orbit. And due to all this information, one of the worst potential outcomes there at the bottom there, or potential problems, depending on where you want to take that, is that if something
I'm
goes
not sure if it was
wrong,
my internet or yours, but it I was only hearing like parts of what you were saying.
it may be me. I was sitting far away from the microphone. I'll actually sit up and pay attention. Um, but whether you want to take it, I'll say potential problems, not worse outcomes, because worse outcomes could be far worse than problems with the telescope itself. But as far as potential problems go, if something screws up or if something is screwed up, like with Hubble, it's not possible to do a spacewalk and fix it.
So you're
It's
talking about a
over.
2 million mile round trip. The best
Yeah,
they could do is send something to it, and that'd be very difficult as well.
yeah. I mean,
So
potential robot or
yeah,
maybe a software update on some of the technology that's inside this telescope itself. No physical
yeah, and
repairs.
yeah. So the fact that you are limited to remote troubleshooting, that's a scary situation, especially when you're talking about the amount of money that was invested into this telescope. It was originally supposed to cost around 800 million,
Yeah,
and by the time it launched, it cost just over 10 billion. So
yeah.
you're talking about it more than
Like
10
more
times.
more than 10 times. Yeah, it's closer
Yeah,
to about 13 times.
yeah, insane how much went into it, but it is totally worth it. It's,
Potentially, it could be
as you know,
worth
like
it. We
I'm a
won't
bit I'm a bit
know
of a
for
yeah.
several months whether it's going to be worth it or not.
It should be.
Well,
I see no
here's
reason
what I
why
mean by
it won't.
that. It's not that I don't think it's going to be worth it if everything works right. The problem is we have another 6 months before it fully unfolds and focuses and starts sending non-blurry pictures back to us here on Earth. So
Yeah.
if anything goes wrong in the meantime and this thing just crashes and burns, it's a $10 billion space trash.
Yeah, it is. It would be the
So,
most expensive trash
yeah.
ever produced by mankind.
Yeah, by a
How
landslide.
yeah. However, the hard part is over. It's in orbit. So
Yeah, I mean, it was
assuming
orbiting, I believe, 32 days after launch, if that
yeah.
sounds about
So
right.
assuming it doesn't get hit by a comet or something. I mean, that's kind of a joke. That's not going to
Yeah, I mean,
happen.
I think it's still in the process of like unfurling and powering up and all that stuff, but it's actually in, I think, what is called L2, which is a
Mhm.
orbital distance from the sun, and it's in
Yeah,
orbit and
that's
there.
exactly where it's at.
Yep.
So, what they hope to find, one of the big things they hope to find is want to see the Big Bang. So, I'm not sure how familiar you are with general relativity, but
I mean,
I
I
mean,
can I can get
you understand the
by.
basics, right?
Yeah,
There's
I can get by.
space is expanding, so it came from this tiny little point. The universe supposedly came from this um, singularity.
Yeah.
We haven't figured out what exactly it means because Einstein's field equations break down. So we're not sure what exactly a singularity is, or if general relativity even applied to the early universe, and if so, what even caused it. So there's a lot we don't know.
Yeah.
So they're
A lot
hoping
of
to look,
questions that happen the further back in time we look. And that
yeah, and so
is kind
they're
of
hoping
the
to look
staple in general.
past. Say it again.
I said that's kind of a staple in general, whether we're talking hundreds of years or we're talking millions and billions of years. But the further back in time you look, the blurrier the image seems to get.
Yeah, but well, we need this. Well, we'll see. I mean, it's not going to be some sort of not expecting some sort of explosion. That's not what the Big Bang is. But however, what they're expecting, what they want to do is look past the CMBR, the cosmic microwave background radiation. Now, if you if the general um if the standard model, as in the Big Bang, is correct, you shouldn't be able to see it because they're in an early universe. Right, the universe was trillions of degrees Kelvin, right after the Big Bang. It wasn't until about 380,000 years afterwards that the universe cooled down enough for matter to be created, for atoms to bond. You know, once you get to about 3,000 degrees Kelvin, the electrons, they'll strip off the nucleus. And you'll have what you call a ionized nucleus just floating around and electrons just shooting around. So you have a plasma. The universe just consisted of a plasma of electrons and protons and neutrons. There wasn't any matter. And the reason that's problematic for being able to see is because photons ain't travel in straight lines that way. Because of just the disorganized nature of plasma and the randomness of it, photons, what they will do is they'll start bouncing in different directions. So you shouldn't be able to see it. So if the standard model is right, we shouldn't be able to see past the CMBR. However, if we can see past it, then we need to do some reworking. So
Right.
scientists aren't expecting to see past the CMBR, but hope to. And that will be very interesting. Another thing they're looking to find is early star formation. So right after the dark age, right after about 380,000 years after the Big Bang,
Mm-hmm.
um, when the universe is cool enough for atoms to bond, the it's the first elements that were forming. It was mostly hydrogen, a little bit of helium, and traces amounts of lithium, but mostly just hydrogen, right? Because it's the simplest element there is. It's just one proton and one electron, very easy to make. So expect to have mostly that, and this was the most common ingredient of stars, the most essential ingredient of a star, hydrogen.
Hydrogen.
So,
Yeah.
yep. So the stars immediately after the Big Bang, those are the ones that burned the biggest, the brightest, and had the shortest lifespan. So
Very
these
easy
were
to make.
just so it's a huge, amazing stars. And so they're hoping to look as far back as they can and maybe see some of these first generational stars. We have not found one yet, but we're looking. We're hoping to see one. This new telescope coming. It is amazingly powerful. I read that it has it could see the heat from a bumblebee on the moon.
That'd be
That's,
insane.
yes, it
So,
is. It has the focus to read. If you were in New York and you were looking through the James Webb telescope, and of course, if the Earth was flat, right? If you were in New York looking through that telescope, you could read a newspaper in Paris.
yeah, that's
That's the kind of focus it's going to
several
have.
thousand miles.
Yeah,
Well,
that's
if it's a straight
so.
line, it's a little less
Yeah,
than
and that's what I'm
that.
saying. Like, yeah, the curvature of the Earth is be problematic.
Yeah, be a little
Yeah,
difficult
so
to
like,
figure out the exact
assuming
distance,
if
but
if the Earth was a flat plane, you'd be able to see that. This is quite the machine. Yeah, so they're looking for they're looking to see the Big Bang, which they probably won't, but maybe we got our fingers crossed. So we may win the lottery here. Maybe Einstein is wrong. He's probably not. Um, we're hoping to see early star formation.
yeah, and
That'll
obviously
tell
we're
us a lot
looking
about
for
the early
things.
universe.
Well, I mean, beyond just early star formation, we're looking deeper into space at stars that are in things like elder stages or just after things like supernova, because basically this is how we know planets form. So, what we do currently with the technology that we have using things like Hubble, which was launched in 1990 and was supposed to be replaced by James Webb in the mid 2000s. Like, Hubble has been operating way longer than it ever should have, which we're very thankful for because we have some of the most stellar astrophotography in the world thanks to the Hubble Space Telescope. With that in mind, it was supposed to be decommissioned years ago, but the James Webb Telescope is supposedly about 100 times more powerful than Hubble, and it's almost infinitely further on the scale of human travel. It's just inconceivably further in human travel time. So it took almost 30, I think 32 days to get from Earth to its orbiting position. And that's traveling in a spaceship, the fastest thing that humans have ever been in. It's just inconceivably far away compared to Hubble, and it's 100 times more powerful. So that's going to give us, hopefully, a lot of insight into things that we've just potentially been missing. The other really
Yeah,
cool feature, I think, the add to that is the infrared technology that we've incorporated into the web. And basically, if you know a little bit about space and what Geo was just mentioning, as far as the early universe, is we know that due to the expansion of the universe, there's this phenomena we observe as something's moving further away. We observe this red light shift, and as things are moving closer to you, we observe a blue light shift, which are on opposite sides of the invisible spectrum, right? Well, this infrared camera technology that we've incorporated into the James Webb is going to allow us to see deeper and look beyond just visible light to observe things like heat radiation and background radiation that existed due to either collapsed or forming stars or etc. Um, and these are all things that we're going to have the opportunity to look at using this telescope that we just don't have now. We're going to be able to see 100 times further than if the Webb was in the same spot as Hubble, but it's also a lot further away. So we're getting multiple benefits, and then we're getting infinitely better picture quality and integrating that technology to essentially look beyond visible starlight to get even a deeper look into space. It's amazing.
Yeah, I say go online and look at the nebula called the Pillars of Creation. Look at the a photo of it and the optical range of the electromagnetic spectrum, and then look at it in the infrared. In the optical, you'll see it only showing maybe like 30 or 40 stars, right? And then when it takes a picture in the infrared, the Hubble did this, and the Hubble's like like you were just saying, the Hubble's infrared technology is vastly inferior to James Webb's, but just with this inferior infrared technology, it was able to reveal like tens of thousands of stars
Yeah, I mean, we
through the pillars
essentially,
of
the
creation.
first thing, as far as what I can tell
Insane.
from NASA and from everything that I've read, and I don't see a reason why not. But supposedly, the first in focus image that the James Webb is going to send back is the same image. Well, not the same image, but I'll clarify. It's the same concept image as the first image back from Hubble. And if you don't know what that was, we essentially pointed to space at this blackness where we couldn't see any visible starlight, and we told it to take a picture. And when we retrieved that picture back, we saw thousands upon thousands of, like, quite literally tens of thousands, if not hundreds of thousands of stars that we just thought were this blackness in space. We just couldn't see them. And then Hubble takes
You're
this
talking about
picture.
the Hubble Deep Field.
Yes, the Hubble Deep Field.
Yeah, galaxies. It's not like, I think you
Well,
said
I,
stars.
I did, but I was,
Yeah.
kind of just saying, like, we actually saw visible stars, but we also saw galaxies beyond those stars. And those galaxies contain hundreds of millions, if not billions, of stars themselves. So imagine going 10 times further and being able to see 100 times better what the potential James Webb holds.
I
It's
know
it's
another
exciting.
thing they're very concerned about is exoplanets because they're really hard to study. One, the only reason we're able to get such good images of the planets in our solar system is because of the sun, right?
Yep.
The sun shines really bright, but other stars and compare it to the sun is they're dwarfed, right? And for like from our angle, right? So imagine a planet that doesn't even produce any of its own light. How hard that is to see, especially if it's next to an object that's glowing in the black backdrop of space. Very difficult to see. The the best just two ways that we can detect exoplanets. One is through the gravitational pull of the star. It does this little wobble because the planet's gravity does a little tug on a star. That's one way. A better way that we do is through um, slight phases in its light. The star get dim just for like a split second or so. That'll be the planet crossing the path from crossing like our visual path from Earth to the star. so you could kind of detect the planet. And they can look through the spectrometer because electromagnetic magnetic waves, when they interact with elements, they follow certain patterns, and we can make generalizations of the exoplanet's atmosphere. What they're hoping to do is with the James Webb Telescope is get even better information of these exoplanets. Being able to see it, I think that is highly optimistic and unlikely. You probably won't be able to get any pictures of exoplanets. I was looking at that today, and because I really want to see an exoplanet. Like you hear about them, but like you want to see it, but
Yeah.
that's unlikely to happen.
Just want to address in the comment section we have in chat from Keith. It says partially incorrect. Hubble. The Hubble Deep Field was way later in the Hubble mission. The first images came back blurred due to the flawed mirror, and yeah, we addressed that a little bit earlier. We talked about essentially Hubble having a contact lens having to be applied. So we did mention that the first images did come back blurry, and uh, I could be mistaken on the. I don't mean
He's right
necessarily the deep field itself, but we took a picture of what we assumed to be empty space, and I'm pretty sure that was
yeah,
the plan for the James Webb as well. We're just going to point it
because
at
it
what looks empty.
was a few of them. There was the Hubble Deep Field, then it was Hubble Extreme Deep Field, then a Hubble Ultra Deep Field. They came a few years later.
Yeah,
Yeah, they were
and
good. They were great photos, it just showed the universe was just is pretty much the same where you look at it, which is another prediction of general relativity.
yeah,
So
and just
Einstein for that, which is why you're probably really not going to be able to see the Big Bang because if the model's correct, you're not gonna be able to see it just
yeah,
because of
just
that.
wanted
Like
to
the
address the
photons
comment
stopped at the
and
CMBR. You're not gonna see anything past that.
yeah, just wanted to address the comment and thank you, Keith.
Yeah.
We don't want to put out even potentially misleading information, so we want to clarify where we can. So thank you for that, and I just wanted to go ahead and address that while it's on the screen and in front of us.
Oh, what up, Keith?
Also, didn't
That's
want
uh,
to
that's that's actually a
interrupt.
buddy of mine,
Oh, okay,
Army buddy.
nice. Well, thank you for the comment, and yeah, like I said, we don't want to ever intentionally put out misinformation, and we want to address comments where we can, and thank you for the jumping in chat. But yeah, so beyond exoplanets, beyond uh, let's see, cosmic background radiation to observe the basic, basically the start of the universe, or the closest thing we can observe to the singularity, which is commonly referred to as the Big Bang. Uh, do you think the government has any hopes of trying to legitimately use it for things like alien life, or do you think that it's just a generic byproduct of assuming that we're probably not going to find any anyway?
Oh, they definitely are looking for that. I mean, like as far as like finding like aliens, like kind of like sort of the stuff that we were talking about a few weeks ago. No, we're not expecting to find like civilizations, but while when they're studying these exoplanets, that's one of the things they're hoping to find, like the building blocks of life. So this actually ties directly into the field of astrobiology. If anyone listening has ever um, did any study on that, I haven't done a whole lot, but that's basically trying to figure out um, the conditions outside of Earth that could produce life. And I mean, it's a that field is in its infancy because we haven't even figured out what produced it on Earth yet, or even if it originated here, we don't know. But that is one thing they're looking for. So they're scanning these exoplanets, and they're hoping to find conditions that are very similar to Earth that may host life, or may even be able to provide the conditions for the building blocks of life, such as water and its proximity to the sun. And And one thing is that the life isn't, at least life as we know it, isn't as limited as we used to think. For like we a lot of times we tend to think in order for life to develop, it has to be within this range of the star, and it has to have this, and it can't, it probably shouldn't be tidal locked and all that type of stuff, whatever. But we found out that one of Jupiter's moons actually gets heat from the planet. Right? So even some of these moons, um, they may be able to host life, even if they're a good ways from the star. There's no telling what the conditions were that life on Earth first developed. And so I don't want to. I think a lot of astrobiologists kind of put um, life in this box, and it
Yeah,
has to
and I
be
think part
it
of
has to
that
be very
probably,
similar to Earth.
yeah, I
I think we're
think
going to
part of that
find out that that's not the
unfortunately,
case.
yeah, I was gonna say I think part of that unfortunately came about due to a ambitious idea, and I'll refer to the organization by SETI. Do you know what SETI is? Have you heard? I'm sure you've heard
I've
of it.
never heard of them.
Oh, well, it's the search for extraterrestrial intelligence. And essentially, I feel like they're the precursors to like astrobiologists because
Hmm.
they were this organization dedicated to the search for essentially aliens or extraterrestrials. But they basically laid out this set of rules that all life had to follow by. And some of those things being it had to be carbon based, it had to have like flowing liquid water, it couldn't have it like oxygen was required. Like there's just a whole list of criteria. They said if any planet wanted to have any habitable form of life, that it had to follow in order to like meet their criteria. Now, we've kind of dialed that back a little bit to just mean life in general versus intelligent life. And I think that's going to help progress our search for potential non Earth based living organisms. But initially, when this started out, we were looking for strictly intelligent beings that would be equivalent or advanced to that of human intelligence. And so we put a ton of criteria on the necessary requirements for what we were looking for when observing planets for potential life. And by
Essentially, little
doing
green men. That's what we
yeah,
were looking for. That's
yeah,
what it sounds
essentially
like.
that's what we were doing. We were pigeonholing ourselves to this concept or this idea that all life had to follow this model and this concept, and I think it came at least in part by SETI. And although their intentions were good, the idea and the concepts, the more we look into it, kind of are bad because they limit things that we look for. Like we know all the requirements for SETI weren't met at the initial stages of what most consider like abiogenesis on Earth. Like they weren't met. It just didn't happen. So why would we be looking for life in other planets that meet those same criteria that even Earth didn't meet at the time of the first stages of life? So I
There's some that are very skeptical that life even developed on Earth. Like maybe abiogenesis occurred somewhere else, and it just evolved here on Earth.
yeah, I mean there's good I mean there's really interesting thought experiments behind that. I've actually, gone into like several thought experiments myself and probably spent way more time thinking about the concept than I should. I probably could do something slightly more productive. But it's really interesting to think, like, oh, perhaps life started on some comet in almost an instant, and part of that comet split and hit the Earth. And then life went from
Maybe it hit
comet
all
to
the
Earth.
planets,
Yeah, maybe it hit
and
a
and,
ton
and
of
Earth was
planets
the only place where
that
it could
was,
actually
yeah, it could thrive.
suitable for it.
Yeah,
Yeah.
exactly. So it's really, I mean, potentially, and we had a really interesting idea or not idea, but an interesting phenomena. Uh, about I want to say like 15, 20 years ago now, when we thought we observed life forms existing on an asteroid, and then we realized, oh, it was just us. We accidentally got bacteria on stuff in space.
Yeah, I
It
actually
was our
remember that,
fault.
and I
Oops.
remember that.
The
They
human
were they
the
were
human
they're
race is
extremophiles is what they
yeah.
were called.
Yeah,
But
the
yeah, we
human
were like,
race
whoa,
is so
life.
bad at trash that we got it on space. Like we're so bad at polluting that we littered an asteroid. Yeah. So good old
Yeah, but
humanity.
I, we were talking about the best outcomes, I believe. That would be the best outcome. Even like that would be bigger than being able to see the Big Bang. Being able
Finding
to look
alternative
and
life.
find. Say that again.
Finding alternative life.
Yes, that would be the discovery of. I was going to say
Humanity.
century. It's going to be discovery of humanity. That's what
Yeah.
that would be.
Yeah, I would say it'd be
And
the
that would
discovery of
be
humanity.
far more important than the Big Bang or even quantum gravity, like anything like that. This would be huge.
Yeah. I would say it would
That would be
undoubtedly
their best
change
outcome.
everything. I
Hmm.
mean, it would change the way we look at things, it would change the way we perceive things, and it would instantly open up new fields of science, research, and technology that we just don't have now. There's questions right now that wouldn't even be considered or needed asking until this event happened. And
What
whole new branches of science would develop because of it.
now? I'm going to like way left field with the speculation here, but I
Hmm.
mean, what would it mean? Like, let's say we got it able to get in touch with, um, let's say we were able to get in contact with one of these um, alien organisms, right? Like
Hmm.
it's bacteria or something like that. I'm not talking little green men. I'm talking about like something very basic. But let's say we got one of it, and he he dissect its genome. It has DNA,
Hmm.
carbon base,
Right?
and actually it shows common descent. Wouldn't that be insane? That would that would validate could validate if that theory or I guess hypothesis that life didn't start here but just evolved here.
Yeah, I mean, it
It
would
would
definitely lend
just a
credence
just a
to it.
random
It
thought.
wouldn't definitively prove by any means, but it would definitely lend credence to the idea that life didn't start on Earth.
Yes,
And that would be, I mean, I think people's minds would just shatter at the concept. And if we
yeah.
could somehow definitively prove that it didn't start on Earth, I mean, it would just alter the course of human history from that day forth. Like
Well, I mean,
literally
even the
everything.
religious implications, but we're not going to go there.
Yeah, I don't even care
It would
about the
be
religious
insane.
implications. I mean, the scientific and
Yes.
technological and informational changes that would have to be made is
Hmm.
just baffling. It's mind blowing.
Another thing they're hoping to do is do deeper study into black holes, which
Yeah,
is probably the most mysterious, most mind bending thing in the universe.
yeah, and by the
There's
way, by far the biggest. Yeah,
Yeah, I mean, definitely. I
that's
mean, yeah, 'cause
a
there
really fun thing.
there's no no theoretical limit on the size of a black hole. It could. I mean, I don't know how it would do this because it does not enough matter, but it could get as big as the observable universe.
Yeah,
So
yeah. I mean,
there
it,
is no size on black holes like there is like on the size of like stars or planets, etc.
and if you're a regular viewer or if you've watched a history of our videos, you know that we essentially, once this gets off the ground a little bit, we want to kind of make this not just a place for debate and discussion, but kind of turn this into an educational springboard and have maybe potentially informational topics on things like how to debate or like logical fallacies or even maybe things like black holes. But I can tell you if you haven't watched it or if you don't browse YouTube quite often, you may have never come across the channel called Kyrgyzstat, and they have a really really good informational educational video on black holes that is animated and visual, uh, and the little bit that we know about them is fascinating. But being able to potentially observe one beyond the really complex algorithm that we use to officially get a picture of one. I think it was either last year or the year before. I don't know. Time's coming running together for me. But in the past year and a half, I'll say, we got the first ever image of a black hole, confirming that black holes exist.
Yeah, they really want to see what's going on with the singularity. I mean, like on the outside, like if think about it, like black holes, they're pretty similar across the board. If you know charge, size, and the direction that it's spinning, you know literally everything there is to know about that particular black hole. It's that singularity that that's very mysterious to us. It goes so. I mean, think about this. So, like, once you pass the event horizon, the singularity is inevitable. And a lot of one thing that people don't realize is that the black hole is not a spatial singularity. It's actually a time singularity. So once you pass the event horizon, space and time is manipulated to such a degree that space swaps places with time. So the the singularity is not a position in space that you can't avoid. It's an inevitable moment in the future. You can't avoid it any more than you can avoid tomorrow. You can't escape out of that black hole any more than you can go back to last Thursday. Like this is insane. And James Webb Telescope may be able to open up some ideas. Maybe it'll help the theoretical physicists who were concocting all these ideas about what might be going on. This may give them some very valuable data from it, and
Yeah,
may
and
give us some more insight into the quantum gravity. So we're talking about really big stuff, right? That this could actually give us direct insight into really really small things, and also the beginning of the universe.
yeah.
It's
So I
really
mean,
exciting.
there's the big picture thing. Like obviously, way better observational skills of things in like deep space. Then there's tiny things like being able to observe like objects nearing or approaching black holes potentially, that could that could potentially get us into things like quantum mechanics, quantum physics, and how planets act and interact near or circling black holes. um and then the obvious ha- concept of looking essentially back in time towards the singularity event called the Big Bang. I, when earlier when I joked that like this is the best Christmas present that anyone could ever have, I wasn't kidding, because there's so much potential in the James Webb Space Telescope that it's like it's so exciting. When I first like started learning about it and like reading about the James Webb, it was probably 10, 15 years ago, back when I was a teenager. And I was like, oh, it's gonna replace Hubble. Well, Hubble's really cool, but like I was still young and stupid. Now I'm old and stupid, but I get a little more of it, and I realize the implications of what something like the James Webb Space Telescope could do. And it's humbling at best. Like it's mind blowing, because that's just a fraction of the surface of some of the things that we could uncover at the very base level of observation with the James Webb Space Telescope. If we ended up just by luck's chance or happenstance finding something like evidence of life existing on other planets, it would just change the entire world as we know it in an instant. Like being able to see back further, closer to the singularity is great. It's fascinating. We may be able to not see the Big Bang, if you will. That
You
may
won't.
be a, we
It's
that
not gonna happen.
chances are that's not going to happen. We may be able to see further back and see greater distances and see how red light shift affects us more so, and we might come up with
Won't
new
see that either.
maths.
It's gonna
Well,
stop at the CMBR. This is my prediction.
we might develop new maths and formula thanks to this telescope. We might find planets that we didn't know existed before. We might find galaxies that we had no idea existed. But
What do you think the worst outcomes could be?
well,
Besides it like
besides,
breaking,
yeah,
like
I mean, like, I don't even
it's
consider that. I would say that
not even
goes
consider
under
that.
potential problems. So potential problems, we can knock that out pretty quickly. One,
Yeah,
it fails completely. And by that, I
yeah.
mean, like, it disintegrates. Something hits it, it, for some reason, the sun goes into a solar flare and burns it up. Um, I don't know.
Oh,
Like, there's,
that shouldn't happen. It got shields protecting it from the sun.
yeah, but if the
That's
sun
another thing
goes
that's
into,
going to
like, a
help it be able
massive
to see
solar
really far.
flare, it would not
Yeah.
only destroy that, it would probably kill a lot of people. So,
I mean, well, yeah, yeah. I mean, if it was solar flare was powerful enough to destroy life on Earth, then yeah,
yeah,
James Webb
probably,
Telescope
probably,
wouldn't
probably
stand a
destroy the
chance. Nor would it
telescope.
even matter, right?
Yeah, I don't
But
think
yeah,
people would. I
but
mean,
but
the
fortunately,
focus would
it has
probably be on the
shields.
solar flare.
Actually, it has sun shields on it, and that's going to keep the temperature very cool. And that's one of the problems that the Hubble had. It was too hot to go very deep in the infrared zone, so it was limited in capacity. But
Yeah,
these sun shields is going to keep it very cool, so it can use infrared, which is going to be great.
yeah, and if you
Yeah. So
go
yeah,
to NASA's
where's
website, you can
out?
actually
Go
see
ahead.
like I was gonna say if you go to like NASA's website and look at the cooling system for the James Webb, it looks an awful lot like a radiator in everyone's car, and there's one distinguishable difference that you would say like is different between that and your radiator. Your radiator is all one piece of these little crumpled pieces of metal together that water flows through, and as it goes through it has more space to kind of cool down, which is what keeps it cool. But it's all one piece. Well, the cooling system on the James Webb is it looks a lot like that, except there's small air gaps in between it, which allows an infinitely better cooling system, which is one of the reasons like this actual design and the build didn't come about until way later than the initial design and concept. We originally had typical style radiator build where it was one piece. And I looked into it a little bit, and this didn't come about until way later. And it basically said it's going to allow us to even get it further and kind of closer to the sun, and just good stuff. So the
Oh,
delay being
yeah.
almost 20 years actually helped us quite a bit.
But besides it, the James Webb Telescope becoming inoperable for whatever reason, um, destroying, going out of orbit, whatever. What's some of the? Let's assume that it's working, just like it should. What are some worst outcomes you think?
So I mean, the worst outcome, obviously, we're just gonna ignore the idea of it being destroyed. Let's say it works.
Yeah, that's what I'm saying.
Um, Worst outcome is that we're like really wrong about some things that the James Webb Space Telescope could point out, and
I'd
it
say that's a
means,
great outcome.
well, here's what I mean by that.
That's going to progress
Let
science.
let me get to the point. It will, but it'll also put us back a lot. And what I mean by that is that we may have to redo maths and science and like astrophysics for years before we actually get it right. Versus where we think we're right now and we may need improvement, we may have to start over. Whereas instead of being able to correct a math problem, we may have to start from scratch. And although the end result will be good, the damper of putting us back on something that we thought we had solved would be kind of disheartening. especially if it's something that's like really important or really basic that we thought we had right. And although, like
I
I said, the end
can't imagine
result being
anything um that could find that would do that. Like I, mean, I can't see it us finding something that disproves general relativity or something like that.
well,
I
like
mean,
what if
but
it shows that we're like
that would actually
really,
be a great thing.
what if it shows that we're like
To find
really
out
really off on general relativity?
could be. I mean, that could explain dark matter. So that, and
Yeah,
that's
that's what I'm saying. Like,
one
what if it
thing.
does that,
I
and
would,
now we have to scrap essentially 40% of Einstein's findings?
wouldn't have to scrap it, but maybe maybe it's not isotropic. Like maybe that space time um say like maybe gravity doesn't act the same everywhere. Maybe there are like like subtle little dips in places. And if they find that, bam, that explains dark matter. You know that makes up like a good portion of the observable universe. That'd be that'd be awesome.
Yeah, I'm not saying end
Worth that, huh?
results, but I'm saying there are. I think there the possibility exists of us finding something that would make us quite literally have to scrap information that we know and start over. And I'm not saying it's going to personally impact me because I'm not smart enough to do the maths behind it. But there's potentially things like parts of the like general relativity that it may completely disprove altogether. And that would mean like instead of us correcting things like general relativity, we have to come up with this whole new concept and now we're behind the eight ball. Whereas with general relativity, we have a fairly good concept of how things work until you get into the quantum level. It's kind of like when Einstein came about and he said that Newton and Newtonian gravity was wrong. Like it's a good thing that we know more about how gravity actually works now, but at the
Yeah.
same time, people that studied Newtonian gravity basically have to start over
Well,
because they're wrong.
yeah. Well, I mean, yeah. I mean, like Newtonian gravity, it wasn't wrong. It was just less precise. I mean, it was Newtonian physics that got us to the moon. At um, the we used Newton's calculations. We use his what you call it, his calculus to get satellites in orbit. Now, of course, you need general relativity for them to work because of time dilation and all that type of stuff. So we wouldn't be able to figure them out on Newton alone. But I wouldn't even say that they're wrong. They're just less precise. And to
Well,
me,
I mean,
I think that would be
basically,
a good
how he
thing.
described how
They can
gravity
figure that out.
works was wrong. Yeah, I mean,
That one more
how,
time.
I said how Newton described how gravity works is wrong.
It's less precise.
It was wrong.
Yeah.
It was, he
Well, I
basically
mean,
said two objects of different masses, the object with larger mass will draw the other one in.
oh,
And that's just
it
wrong.
does.
That's not how it
Does
works.
do that. The problem Newton had, the main thing with his model, because for him, gravity was acting almost as like a magnet. It was just a matter that was just attracting each other. It wasn't bent in space time. And like one of the main problems he's had was like like instant causation. We were talking about a few months ago. Like, the what if the sun was to instantly disappear? What would happen to the orbit of the Earth? So under Newton's model, it would immediately Earth would immediately just start slinging out into interstellar space.
Hmm.
That's problematic. Like like instantaneous causation doesn't make any sense. And he even questioned Newton on it. And he was just like, I don't know.
Yeah.
So yeah, Einstein
And
perfectly
obviously,
described that.
Newton didn't really focus too much on like the speed of light, which is where like the whole general relativity gets foundation,
Yeah.
because like instantaneous transmission isn't something possible when you have a cosmic speed limit.
Maybe, maybe, because like I mean, I don't want to get too deep into it, but like quantum entanglement, that's literally what that is.
Well, you're talking
Right.
about
So,
things like spontaneously popping in and out of
No.
existence.
That's quantum fluctuations. I'm talking about quantum entanglement.
Oh, you're
When
talking
two
about like
two
when
two
two
particles,
things
yeah,
basically
they
getting bound
develop.
together at the
It again.
quantum level, like two things getting bound together at the quantum level.
Well, yeah, they get bound together, but they get entangled in a way that even when they're separated, so they're let's say they're a million miles away, and
If
so
something happens to
one
one, it
becomes the
still happens
opposite.
to
Of,
the
you
other.
start spinning one up, the other one starts spinning down, and it happens at the same time.
Yeah, I did
This
a little
instant.
research into this, and I only because I came across an article of a company that was trying to quantum entangle a tardigrade, and
Tardigrade, what's that?
it's also known as a water bear, but it's undoubtedly the most resilient living creature on Earth. It is this tiny, quite literally microscopic living creature, multicelled organism called a
Oh, that,
tardigrade or a water
well,
bear.
yeah,
We've shot them into
you gotta do it
space.
with a
We've
particle.
boiled.
You can't
Yeah.
do it with a.
Oh no, we claim that we did, but
You
there
said
was
they
some,
quantum entangled a living creature.
yeah, with a laser, and they basically used a laser to rotate something like 330, like I want to say million rotations per second to quantum entangle a tardigrade. And of the
Because
five test
so even
subjects, four of them died.
because I mean even like small creature, like bacteria, something really small. I mean, it's still composed of like trillions of particles.
Yeah,
Like you have to do this with something really tiny, like an electron.
yeah,
You
well
got,
aware.
you can't
Which
do
is
this
why
with.
there
I
was,
mean,
which is why there was an
but
issue
I
in
don't
the
know.
claim of us quantum entangling a tardigrade. But
Yeah.
yeah, beyond that,
I gotta
I
look
would say,
into that. That's
yeah, feel
crazy.
free to check it out. And if I can remember, I'll put the link to the study in the comments and in YouTube and on Twitch or wherever. And put the info there. So if anyone wants to look into it, basically we claim to quantum entangle a tardigrade by using a laser to rotate some some particle at a ridiculously high speed. And I wasn't even that fascinated by the quantum entanglement portion. I was trying to wrap my head around how RPMs didn't equate to breaking the speed of light. And I just went down a rabbit hole. But that's
Oh,
me.
yeah, because the speed of light. So, well, I mean, let's see. So, special relativity, it's not about speed. It's actually about causality. So, like, you could take a, let's say you had a laser that was powerful enough to hit the moon, right?
Yeah.
And now, when a laser is really far away, when you move it with your hand, uh, the laser, the dot that's on the object that's really far away, is moving much faster. It's moving at a much faster speed than your hand, right?
Yeah. Yeah.
So, so let's say you put it on the moon. Like the farther the laser's going, when you move it, the faster it's traveling. So you could do that and actually break the speed of light. It'd be going way faster than the speed of light. Let's say you did it and pointed it at the Andromeda galaxy and just moved the laser across. That laser went across the Andromeda galaxy way faster than the speed of light. Right?
Mm-hmm.
Because Andromeda galaxy, it would take like a few 100,000 years or so to traverse the Andromeda, right? But that laser just went across in like a second, right?
Right.
Because is speed, special relativity is about causality. It would take the photons a wicked amount of time to reach the Andromeda, right? Because your laser is directly causing the light that shine on that galaxy,
Right. It's
right?
emitting the
But,
light that hits that
yes,
galaxy.
but as it moves across, none of that is correlated. The- I'm sorry. There's nothing about that causes the other. So when it moves, it's like if you move it from left to right, as it's moving, there's nothing relating to causality about that because the cause is from your laser. That's how you could cheat and break the speed of light. It's about causality,
Yeah,
not
I watched
necessarily
an
speed.
Yeah, I watched an
You can do
interesting
that trick.
video to kind of help me understand this because they were like, is dark faster than the speed of light, or specifically shadows? Are shadows faster than the speed of light? And they gave the example of pointing a laser at the moon and then putting your hand in front of the laser, right? Like,
Yeah.
your hand can quite
I say
literally
dark.
block the
I say
light.
dark's not really a thing,
Well, shadows.
or
That's why they
neither
specifically
shadows.
said shadows.
Yeah.
But like, you cast a shadow between a light source and its projection. So your shadow can move across. Like if you had a spotlight pointing at the moon, you could move your hand across, and your shadow could move faster on the moon than the speed of light.
Yeah. I mean, essentially, yeah. I mean, so because this is moving across, like there's when it's moving across the moon, there's nothing regarding causality. Like it's not like the shadow on one side of the moon is causing the shadow on the other. Get off from your hand. So the information, as in the lack of photons that's emitting in that shadow, that can't travel to the moon faster than the speed of light. That's causality.
Yeah.
So yeah, but it could travel across the moon faster than the speed of light. That's yeah. We're getting a little late. I wanted to talk about what I think were the worst outcomes. My opinion, I for me the worst outcome would be learn nothing.
Yeah, I can't
We, we
foresee that
we
happening,
go
but
out
that
there,
would
we look out
be
there,
an
and
impressive
we
waste
just
of money.
confirm everything that we've already known. I would thought that would be very uninteresting.
I agree. I think that would
It
be
would it
one
would
of the
make people
worst
think this
outcomes
was
that
a
we could
waste of
imagine.
time. It would,
Not only a waste of time, a waste of money, and a waste,
yes,
like people that have dedicated quite literally their whole life to ensure that this works would probably feel like
yes,
their life would have been wasted.
and it'd be very difficult to get another one. So think
Yeah,
about this: like, hey, we spent $10 billion, and guess what we found? Everything that we
nothing.
thought was right.
Yeah, we just confirmed the information that we already knew.
Yes, that would be very boring.
Yeah, I agree. Well, uh, I think that's going to be it. We've hit our typical time limit. We were a few minutes late, but we made up for it on the back end. Uh, Next week should be same time. We have our sound cleared up and cleared out, so I should, and I'll put it up on the screen to anyone watching. We should start with a video that looks like this next time with the actual countdown timer and background music like we were doing before. In the meantime, we'll have a topic. If anyone has topic recommendations or suggestions, anything that you'd like us to discuss, even if it's not necessarily like a debate, although the debate channel is called Now That's Debatable. Obviously, we like enjoying having just discussions, and we like to have, countering points on the measure, even if it's not an official debate. Things like the James Webb Space Telescope is something that we both have enjoyed and both have looked into on our own. And we didn't even have to do a ton of research on our own to kind of be able to talk this whole thing out. And with that in mind, we do thank you for watching if you did watch, whether you're doing it live. Thank you to Keith for tuning in with his comment. Thank you to anyone who watches live or otherwise, and please feel free to reach out to us with any questions, comments, concerns, feedback, topic suggestions, etc.